So today we'll be talking about innovations. Okay, so describe the innovations relating to the reduction of greenhouse effect from the carbon emissions to marine diesel propulsion plant. But the topics that we'll be focusing is not on scrubbers. So we will be focusing about human-machine interface (HMI), energy recovery systems, fuel efficiency, and maritime just transition decarbonization by 2050. Okay, so let's start. So marine engineer is a noun. So a person who solves problems you didn't even know existed by using precision guesswork based on unreliable data provided by those of questionable knowledge. Also see wizard or magician. So it's not really in the Webster's dictionary, but some say that these are the description of a marine engineer. So maybe they are also wizard or magician. Okay, so let's start. Okay, so this is a ship. So maybe this is a supply ship. So it has the main propeller at the back and azimuth thruster in here, azimuth thruster on the front, and some bow thruster to move the ship left to right. Okay, we have the power system from the generator, power generation, power distribution, power management, and backup power UPS. It's in here in the engine room. And then it is connected by a DP controller with process stations and IO systems. And then connected to the bridge. So this is the bridge. This is where we control how the ship is maneuvered. So it has connection with a GNSS satellite system, hydroacoustic, laser, microwave, taut wire, so position reference systems like the satellite, the gyro compass, the wind sensor, the MRU. We have sensors, compass, wind, vertical or motion reference unit, draft, and sea current also in here. And then also in the wheelhouse, we have the operator console or the human machine interface. So the HMI computer, the operator panel, and the display screen. So in these ships, so we can directly control the engine, the azimuth thruster, the bow thruster, the generators, and all the processings are connected into one computer on the bridge, which is connected with the human machine interface computer, so the HMI computer. Okay, so what is a human machine interface? So in the late 1970s, we do have big hardware system hardware controls. We have big computers at that time. And during the 1980s, the Microsoft had this computer desktop. On 1990s to 2000s, we now have the touchscreen tablets and the cell phones, the touchscreen smartphones, yeah. And 2010 and beyond, we now have the more advanced human-machine interface. Especially today, nowadays, we have the gesture-based virtual assistants and virtual reality. So we have VRs. We are using VRs in our technology today, and that's where we are now in the human-machine interface. So we are, by the day, we are upgrading, we are innovating. So we are improving day by day in our technology, and that technology will be used on in the future or currently been embedded into our maritime sector. So these are HMI. So maybe in the future we will see something like this, like Iron Man. Yeah? Then we can check the engine if there is a problem using the twin digital technology, in which you can see your engine and you can see a digital twin of your engine also. So digitally you can check the engine and then if there is a problem. Okay, so intelligent virtual assistants are being embedded in products across every industry, like in the Netflix, in the Amazon Echo, in the Siri for the Apple. So intelligent AI is now embedded in our technologies. So we have the gesture-based HMI. Gesture-based human-machine interface accepts input in the form of hand or body gestures, just like what we see with the Iron Man movie. These interfaces are highly intuitive but face several challenges at the moment. But surely, through various, as you can see in here, 2018, there is a $15 billion of market that grow 30% annually in this gesture-based HMI. So potential barriers of adoption, there will be different challenges, but surely this will be the future. Okay, so human-machine interface in marine diesel propulsion and environmental protection. So discussion, the human-machine interface plays a crucial role in modern marine propulsion systems, especially in achieving energy efficiency and reducing carbon emissions. So HMI refers to the technology that allows human operators to interact with and control machinery systems and software efficiently. So in marine diesel propulsion, HMI advancements contribute significantly to operational efficiency, safety, and environmental sustainability. Okay, so the role of HMI in energy efficiency and emission reduction. So modern HMIs are designed to enhance the efficiency of marine diesel engines through automated monitoring and control. Advanced control panels, touchscreen displays, and digital dashboards allow engineers to monitor engine performance in real time. So this helps optimize fuel consumption and reduce unnecessary emissions. So modern HMIs are designed to enhance the efficiency of marine diesel engines through integration with AI and data analytics, just like this one. We have data analytics of the different parameters inside the engine. So smart HMI use artificial intelligence and big data analytics to predict fuel efficiency trends, optimize power settings, and detect engine faults before they cause excessive fuel burn or emissions or maybe damage to the engine. So with AI, they are now having this machine learning. They have the theories embedded in them, neural network, and the big data and other algorithms and data mining. So they are improving as time goes by. So through remote operation and diagnostics, engineers can now remotely monitor and adjust propulsion settings, ensuring optimal engine operation under different sea conditions, minimizing fuel wastage and reducing CO2 emissions. So you will, as the chief engineer, you will be like Iron Man. So Iron Man can do these things remotely. So alarm and safety systems. So modern HMI systems provide real-time alerts about engine malfunctions, excessive fuel consumptions, or environmental violations like for high NOx or SOx emissions, allowing for corrective actions. So as you can see in this picture. So that's how HMI is. And the next, how to make the ultimate green ship. So with the help of HMI also, so nowadays we have this technology, this one. This is the kite sail system. It can reduce fuel consumption by 20 to 40% annually. So this kite system is operated by AI, in which the kite will be pushed by the wind, and then if the kite will push the wind, also the ship will be pulled by the kite, reducing the fuel consumption of our main engine. Okay. Also, we have the rig sail system. The rig sail system is like in the time of Magellan, in which ships are just moving because of the push of the wind through sails. But with this rig sail system, this hybrid system can save fuel up to 30%. So this is also computer operated. So with the use of AI, with the use of the different sensors attached all over the ship. So you can use this hybrid rig sail system to create a fuel savings up to 30%. Also, with the current technology, they are now also going into the solar sail system. So this hybrid system can save fuel up to 20%. So they are having the wind is pushing these sails, and also there is a conversion of the sun or solar energy is converted, and this energy will be used inside the ship, so it can save fuel. So we will be having lesser consumption of fuel, and also in generators. So there are different improvements to make the green ship. Okay, so another one we have here, we have the sandwich plate system. So it is helpful in green recycling of ships. So if you want to recycle the ship, so you can use this sandwich plate system. Also, the improved hull paints. So these paints reduce friction, creating fuel saving up to 8% to our ships. Also, in cruise ships, they are using this air bubbles hull lubrication. So they are giving breathing out or giving out air at the bottom of the ship. So the purpose is this one is to reduce the friction, to increase the speed of the ship. So it will also give us fuel saving up to 10%. Okay, we have also the green propulsion. So in our main engines nowadays, they are using dual fuel engines. They are putting water in fuel, so to bring down the temperature of the exhaust, resulting in as lesser or smaller NOx emission. Also, we have the exhaust gas recirculation to lower down the NOx emission, and the fuel cell technology, in which the energy produced by the solar or from the generators will be put in the fuel cell technology and will be of use anytime you want. So this is reduced SOx up to 100% because of dual fuel engines. SOx emission up to, or sulfur oxide emission up to 100%, and NOx up to 35% reduction. Also with our propellers, they are incorporating the speed nozzle, so it increases efficiency at higher speed, fuel saving up to 5%. And then with the advanced rudder and propeller system, the new design can save fuel up to 40%. Okay, and also with our engines, the engines will now go to our exhaust scrubber. So in this is exhaust scrubber, so SOx emission is reduced by 98% because of the installation of the scrubber system. And then with the use of this optimized cooling system, it can save 25% of electricity, fuel saving of 1.5%. So these are the different improvements or innovations that are currently being employed on our merchant marine ships and vessels all over the world. So they are really going into the goal of the 2050, the IMO goal at 2050 to have zero emission and better efficiency for our ship. Okay, so let's go with the examples of HMI innovations in green marine technology. So first we have the electronic engine control system. So we have a different brand for this one. In this picture we have the EcoMate brand. So this digital fuel injection control improves combustion efficiency, reducing unburned fuel and CO2 emissions. So these are embedded into our auxiliary engine, main engine, and the fuel oil system for the boilers. So with this, they can measure the parameters, the computer with electronic engine control system. So, and even the bridge can do something for the ship. Okay, we have the smart bridge consoles. So this integrated bridge system provide an intuitive interface for engine power management and emissions monitoring. So, helping ship operators maintain compliance with MARPOL Annex 6 regulations, air pollution. So, also the bridge is there are smart bridge consoles installed in our bridge. So, this is a very great um, used for managing our engine. Next, we have the real-time energy performance monitoring. Okay, so systems like variable frequency drives, like used in our thrusters, so VFDs and shaft power meters, allow engineers to adjust propulsion power dynamically, reducing energy waste or wastage. Okay, so we do have these variable frequency drives in which we can control the speed of the engine or speed of the um, rotor. So the speed is controlled by adjusting the frequency of its uh, drives. Okay, next. So these are the shaft power meters. So in our shaft going to the propeller, so we have the propeller shaft. So in this propeller shaft, I put a contactless power supply unit with detector ring inside, and this one allow engineers to adjust propulsion power dynamically, reducing energy wastage. So you can measure the torque and the RPM, and then you can adjust depending on the optimum adjustment that you can use at the given moment. Also, with the IMO's goal of achieving, so HMI in the future of maritime just transition decarbonization 2050. So with the IMO's goal of achieving net zero carbon emissions by 2050, HMI will play a key role in integrating alternative fuels like LNG, ammonia, and hydrogen into existing propulsion control systems. So as you can see in the picture, we have here a dual fuel engine in which gas fuel is injected during the intake stroke. So it will go in to the engine, mixing with the air, and then the air is compressed, and then another liquid fuel will create a combustion or the spark, and then there will be combustion during the power stroke. So with this system, they are reducing the pollution that have been produced by ships, especially the SOx and NOx, which contributes with the changing of the weather or the global weather changes. Okay, so also training seafarers in digital engine management, reducing the skill gap as the industry transitions to greener technology. So we have here instructors, we have simulators, we have virtual reality simulators also. So you can really train seafarers with the current trend. Okay, also ensuring compliance with emission regulations through automated logging of carbon footprints and performance data. So all the information are logged in automatically in the HMI, and then we can adjust our engine depending on the data that were computed or were logged in the system. Okay, so in conclusion, the implementation of smart HMI systems in marine diesel propulsion enhances fuel efficiency, reduces greenhouse gas emissions, and ensures compliance with environmental regulations. So as the industry moves toward decarbonization by 2050, HMI will be essential in achieving energy efficient and eco-friendly shipping operations. So that's it. So I hope you learned something. You can comment down on what topics you want me to discuss more, or if you have certain topic specific on your mind, you can comment it down below, and maybe I'll try to make a video on those topics that you want me to discuss. Okay, so I hope you learned something today. God bless, and I'll see you on our next video. Bye bye.